you need to know about circles. The first thing you need to know is what the locus is. And the locus is a set of equidistant points to a fixed point, also known as the center, in a two-dimensional plane. And the important thing with circles is that you're able to convert standard form and general form in between each other by using the completing the square method. So when you're graphing a circle, you just take the center, which will be 6, -1, as you can see here, and the radius, and you plot the center, and then use the radius to plot the rest of the points on the circle. So this problem is written in general form, so you're going to complete the square and put it in standard form. By doing that, you're going to separate each of these sections, and then divide this number by 2 and square it. Then add each of the numbers that you get to the other side, and the 9's cancel out and you get 36 for that answer. Then you are going to square root each of the sides, and you'll have your center and your radius. So this is what you need to know about ellipses. And ellipses are a set of all points x and y in the plane such that the sum of each of the distances from f1 and f2 is d. And the important distinction between ellipses is that one is horizontal and one can be vertical. In the horizontal ellipses, the major axis is over the x coordinate plane. In a vertical ellipses, the major axis is in the y coordinate plane. The center will always be found at HK, and to distinguish each of the points, you just add or subtract the center So this problem also starts in general form, so we need to place it back into standard form by completing the square. Then once we complete the square, we're going to look at which one has the major axis. And because 36 is underneath the y plane is our major axis, and this is vertical. So now that we know it's vertical, we know that we have to add, to find our vertices, our major vertices, we add 36 square root, which is 6. So it'll be 2, 7/2 plus or minus 6 for each of our vertices. Then to find our end of minor axis, we just take the square root of 9 and add that to our x value. When we find our c, we are going to add 9 and 36, and then we're going to square root them, and you'll end up with the square root of 27, or 3√3. And then to find our e, it'll be c over a, which will be 3√3. Then to find our e, we'll do 3√3 over 6, which is our c and our a, and that'll be our eccentricity, and the closer it is to 0, the more circular it is. And then to find our focus, we just take our e and plug it into our y plane.
So a hyperbola is a set of all points in a plane such that the absolute value of the difference of each distances from either side is a constant distance. Now this can be explained more thoroughly by looking at this diagram. So in order to interpret this, it basically means that from f1 to x2 and y2 is the same as from f2 to x1 and y1, which is also the same as f1 to x1 and then f2 to y2. Okay. And so our standard form of a hyperbola is for the horizontal side, it's going to be here, and it looks like this on a graph. And then the vertical standard form is as so, and it's going to look like the switch or the reflection of your horizontal. Now in looking at a hyperbola, you need to know a set of specific things. Now those sets are going to be your center, which is your HK, 2A, which is right here. It's going to be your distance between vertices, C, which is the distance from the center to the focus, which is going to be from here to wherever it is depending on your graph and your problem. And how you get C is going to be from here, which is c squared equals a squared plus b squared. Your eccentricity for a hyperbola is going to be c over a, which you get from here. And then your conjugate axis is 2b, and your transverse axis is 2a. So for a hyperbola example, we took this equation that is in our standard form, and just by looking at the equation, we know a few things. For example, we know that -2 and then 0, which can be assumed, are going to create our center, and it's going to end up being 2, 0. And from there, we also know, just from the equation, is that our 4 and our 25 are our a squared and our b squared, and that can lead us to what c is. And since a squared plus b squared gets you c squared, we're going to take 4 plus 25, which gets you 29. Since 29 is not a pretty number, we leave it as the square root of 29. And in knowing that from the square root of 29, we can end up getting our foci. And since this is a horizontal hyperbola, we're going to add it to our x, and it's going to be 2 plus or minus the square root of 29, 0. That gets you our foci. And we also know our vertices, because our vertices are going to be 2a added to our x side, and it's going to be plus or minus a, sorry, not 2a. And so it's going to end up being 4, 0, because when you take 2, which is the square root of 4, and you add it to 2, you get 4. Now when you take 2 and you subtract it from 2, you get 0. So these are our vertices. And then also we can get our asymptotes, which is going to get you y equals plus or minus 5 over 2 times x minus 2. And this is going to be our b and our a. And since we also know these numbers, we can get our eccentricity. That gets us 29 over 2. The closer it is to 1, the better. Gets us the more perfect hyperbola. And we can also get our conjugate axis, which is going to be 4. And our transverse axis, which is going to be 10, because it's going to be taking our 5 times 2. And then over here, you can see how it would look like graphed. This being our center. Yeah. A parabola is a set of all points equidistant from the focus to the directrix. Now this can be better explained from this diagram. So if this is your focus and then this is your vertex, it's going to look like that, where it's all going to be equidistant to each other. So the standard form of a parabola for vertical is going to be right here. And then the standard form of a horizontal parabola is going to be right here. Now the major differences here is that your y area of the problem is squared, versus here your x area of the problem is squared, versus this one is not, and this one is not. So for your vertical parabola, it's going to look as so, and your focus is going to be when you add p to k, and how you get p is going to be the distance. The p is your distance from the vertex to the focus, and you get it by dividing whatever this number is by 4. And also for vertical, you're going to need to find your directrix, and your directrix is when y equals k minus p. Now on your horizontal side, your focus equals h plus p, k, and then your directrix is x equals h minus p, and it looks as so. It's kind of like a rotation that way, or the other way, depending on if it's positive or negative. So now there's some things, important things that you need to know, which are different from your hyperbola, your ellipses, or your circles. Your HK in this scenario is not your center, it's actually your vertex. And your vertex is going to be right here. And then other than P, which as stated before, you get by dividing whatever number here by 4, you also need to know your latus rectum, which is just this number alone. Now, for our parabola example problem, we take this equation, which is already nicely in standard form for us, and just by looking at that equation, we can tell what our vertex is going to be, because in a parabola, we know that our vertex is our HK rather than our center. So because of this, our vertex is going to be -1 and 3. And also just looking at that equation, we can tell that our P is going to equal, which we're going to take this number, and we're going to divide it by 4, giving us -2. Now that we know what that P equals, which is very important for us, we can end up getting what our foci is. So we're going to keep this -1 the same, and we're going to add P to our K. So that's going to be -2 plus 3, getting us 1, creating our focus. Also, in knowing that, we know what our directrix is going to be, which is going to be y equals K plus P. So that's going to end up getting us 5. And then we also know what our latus rectum is today, and it's going to be -8, because we're just taking and bringing this term down. Now looking at a graph here, this is going to be our vertex, our foci, as seen here. And then we can also know that from here to here, it's going to be negative 8. Thank you.